Well, hello everyone, and welcome back to Adrian's Digital Basement. If you're a regular watcher of my channel, you probably know that I have a big soft spot in my heart for the original 8-bit Nintendo Entertainment System, aka the Nintendo Famicom. This 8-bit console based on the 6502 was the game console that I had when I was growing up. I had, of course, computers and stuff, but this was the first game console that I actually bought with my own money, and I loved this thing. While there are lots of merits to other 8-bit consoles of that generation, certainly the Nintendo had a good combination of capable graphics, expandability with the mappers, but then also really good software written for it, of course, starting with the original Super Mario Bros. By Nintendo. Now, in this day and age, it's trivial to emulate something like the Nintendo, but I personally feel that even in 2026, if you want to run original Nintendo software, it is really best to play it on original hardware and using a CRT. That way you don't have lag and you have the most accurate representation of the way the games were compared to when you were a kid. Now, Nintendo sold millions and millions of these consoles back in the day, so there are a lot of them out there, so they're not impossible to find. But prices are going up and it is getting harder and harder to find the original hardware. Games, on the other hand, are still plentiful, not to mention you have good emulation options like the EverDrive available to play on the original hardware. But again, finding the original hardware is just getting harder and harder. Now, there are third-party clone devices like this little device. This is the Yobo console, and there are a zillion of these things out there. I made a video on testing these clones, and I'll link to it in the description below if you haven't seen it. These provide an okay approximation of the Nintendo hardware. It's not emulation, but it is recreated in silicon, and it's not always done very well or very accurately. Not to mention the video quality and sound quality can be very varied with those, and no matter what, you're always going to have some glitches compared to running on original hardware. So that brings me to the topic of today's video, which is this little clone NES, which I found on Aliexpress. It goes for just $22. And while it's a recreation of the NES, it still uses the original CPU and PPU, the picture processing unit. That means this thing is going to be 100% compatible. So let's investigate whether this clone is as compatible as I think it should be, if it produces good video and audio output, if it's glitch-free, and what these 4 controller ports are all about. And for 22 bucks, let's see if it's even worth that much money. So without further ado, let's get right to it. Let's start by taking a look at this little game console. So right off the bat, you'll notice that the acrylic case, which is definitely a little bit homebrew looking, didn't really survive shipping. So we got crack there, crack here with a missing piece altogether, and also a piece in there that is broken. Now, when I received this, I actually emailed the seller and I let them know that it didn't survive shipping. And the problem was they just had it in a little cardboard box with essentially no packing material. I think it had maybe one thin sheet of bubble wrap, the thinnest of sheets. And of course, international shipping, this thing got banged around a lot and got crushed by some other things. And well, the acrylic cracked. So I asked them if they had any STL files they could give me and I could just print a new case. And the seller said that they would reach out to the manufacturer. So I guess it was a third-party seller of some kind, and they would get back to me and hopefully be able to get those design files. The front of this console is obviously 3D printed, this part right here. So I figured there would be STL files so I could print the rest of it. But unfortunately, I never heard back from the seller, and well, for the price, it didn't really matter. The console itself, I don't think is broken. It's just cosmetically doesn't look as good as it could look. Now, I mentioned in the intro that this uses the original CPU and PPU. Now, the funny thing is, when we look at the 2 chips that are on here, which is what came with this console, they look like they took a red marker and drew over them, and then there doesn't appear to be any markings on them either. In fact, looking closer now, it looks like all the chips actually have had their markings covered up with a red Sharpie. I'm not sure if that's for a stylistic thing or what, but it's definitely kind of amusing. Now, the reason why I think this console is going to be 100% compatible is because it really is just an original Nintendo. Here's a random board that I have. We have the CPU and the PPU 40-pin DIP. Those are the same on both of these. And then we have 2 SRAM chips, which are right there. This is the lockout chip, which doesn't exist on here. And then we just have these logic ICs. Now, oddly enough, there are 4 of them here, and there really only appears to be 2. So they've done some re-engineering of this to probably minimize the number of components. But otherwise, I think this should be 100% compatible because honestly, the heart of these game consoles is the CPU and the PPU, and they're obviously, well, I don't know if these are real parts, but they're certainly compatible with the real thing that are on this board. Now the NES front loader has the RF modulator that's also handling the power input, and it's handling the conversion of the video signal from the PPU to composite video and also RF output. It goes without saying that this board has a much more simplified output, where this is the power regulation stage, so it uses a little small buck converter as opposed to a linear regulator like this one uses. And then we have to imagine that they have recreated some of the video output circuitry. This will be the video connection right there. Yes, it is. And that makes its way over there. And we can see some small transistor and capacitive components, and those will be creating the video output circuitry. We'll see if the video output levels for the composite output are accurate on here, and if they need any mods, maybe those are the parts right there that I'll have to switch out to kind of get this thing to be more accurate. But I have a feeling this should produce a relatively clean image. And depending on how they route the video signal, it looks like it has some guard ground traces around it, so that flood fill is ground. That's good. If they keep it away from any of the data signals that are on the board, that should eliminate the jail bars, which this NES does suffer from a little bit, just because the routing of the video signal is not great. Because if I recall, the composite output that comes from the PPU makes its way close to these ICs, and obviously we have some digital signals. Now it's funny to look at this clone console and see that there are 4 controller ports, and you might be wondering, how is that actually working? Well, I think what they've gone ahead and done is they wired up those 2 additional controller ports to act as the external controllers for the original Famicom. In case you're not familiar, the original Famicom has hardwired controllers. So Nintendo added a 15-pin expansion connector on the original Famicom, and this allows you to plug in external accessories like, say, a keyboard or the zapper, but also even regular controllers. And there were adapters that went from this port to the standard-looking NES controller port that you see on here. Sorry, that's kind of a weird way to hold it, but that shaped controller. And believe it or not, many Nintendo games support having the main controls come in through controller 1 or 2, which on the North American NES just are the 2 ports that are on the front of the console. But it will also support using controllers that are plugged in externally through this port. And I have a feeling when we get this thing fired up and we put in a game, say like Tetris, for instance, we can plug a controller into this port or this port, and they will both work as controller 1. And the same for these 2, it will be controller 2. Now in North America and probably the rest of the world, Nintendo released an official adapter that plugged into your standard NES and would allow you to have up to 4 players. And only games that supported that device actually worked with it, because I think it did some kind of multiplexing with the signals going into controller ports 1 and 2. It did not use the expansion connector on the bottom of the NES. It still plugged into the front. So games that use that multi-tap for sure won't work on this, because we don't see any additional chips on here that could support that type of multiplexing. And I noticed some bad reviews on the Aliexpress store for this clone console where people were saying, the other 2 controller ports don't work. Well, I think they just didn't know how they were supposed to work, and we'll test that to see how they're actually wired up. Incidentally, for the front loader NESs, there is an adapter now that can plug into the bottom of the console, because this motherboard's mounted like this, and that will give you those additional external controller ports that the Famicom has by plugging into this. All the signals that are on this connector are available on the expansion port on the front loaders. Now, unfortunately, they could have easily had a little D sub connector on the side of this that also exposed those same signals that the Famicom uses in that standard pinout, so you could use regular Famicom accessories, for instance, the keyboard from the Family Basic or other accessories designed for that port. But they didn't, and they probably did it for cost reasons, but they could have at least put the footprint on there, so you could have added the connector yourself later and, yeah, made a new case or whatever. But anyways, they could have improved that a little bit more. Now, from a size perspective, you can just kind of see how small this thing is, and that's one thing that's really quite cool about it. And even compared to the Yobo, which was the other small clone console, it's still even smaller than that. So it's neat how little it is. Now, what is also cool about this is this does not use the cartridge connector from the Famicom. Here's a Famicom cartridge. That does not plug into there. This is designed just like this console to use these types of cartridges, and they plug directly in. You just have the label facing forward. And if you have an NES with a flaky front loader mechanism, well, this could be a good way to get away from that particular problem. This Yobo clone console, same thing going on. It is also designed for these types of cartridges. What I like, of course, is this has a cutout in a case, so you can't put this in backwards. While this thing, you could obviously plug the cartridge in either way, since the top cover doesn't have any of that notching going on. So if you're allowing, say, young children to use this thing and they're not careful, they could accidentally put this in the wrong way and damage the game and or console. Now, previously on the channel, I've talked about my other favorite clone. That's this, the Lava RSC. And what this is very similar to this in that it has the original PPU and CPU in it, But there's also an FPGA over here. You can just sort of see it through the clear case, which is essentially the NES RGB. So that's a project that's existed for quite a while, and you can get those NES RGB FPGA boards to actually attach to something like your original NES as well. And the thing about the Lava RSD is it has the composite video output plus audio, but then it also has an AV out connector from a Sega Genesis 2. This has RGB and S-video on it, so you get much better quality video, even with S-video, for instance, compared to something like this with composite output or even a standard NES. The original NES PPU only outputs composite video, so to do anything higher than that, like the RGB that's on here or the S-video, you have to use an FPGA that does some interception of signals and stuff like that to create a new video signal that is then output through these jacks. Now, one other thing about this is the color palettes this outputs aren't exactly the same as the original PPU, because the video signal you're looking at, even over composite video, is not generated by the PPU. It's generated by the FPGA, and then that gets converted into S-video, composite, and RGB. Now, when it comes to the price of this console, let me come clean a little bit. So I kind of showed this screen during the intro, and the price right now is $23.08, and it has $8 in shipping. So it's actually $31 shipped. But the other caveat is that it's the PAL version that's that price. The NTSC version is more like $45. And the reason why I think that is probably because of the chips that are on here, the PPU and the CPU. They're different parts for NTSC versus PAL, and the PAL ones potentially are more common, or maybe the clone versions of the chips are more common because the markings are rubbed off on here. We don't really know if it's even an original NES part on here or not. Probably not. So that means it's a clone chip, which might also introduce some issues, kind of like the Yobo Blob console that I mentioned before, with worse video quality and potentially some sound issues too. Now, what I ended up buying is the PAL version of the console, and I did that for a couple of reasons. One is that I don't have any PAL NESs, and I thought it'd be kind of fun just to have one, so I could experience what it's like to have games that run much slower than they should and have the music all be off tune. There's always a lot of fighting over, which is better, PAL or NTSC, but the truth is, Japan uses NTSC, and they run at 60 hertz there. And having talked to my friends abroad about what it was like playing these 8-bit consoles in 50 hertz markets, they all said it kind of sucked because the games just don't work right and they're too slow. And once they started playing on NTSC, they realized, whoa, this is how the game should be. And they all sort of regret having been forced to play on the 50 hertz versions of these consoles. Now, certain games did have versions that were released in 50 hertz markets to try to fix the timing and fix the music. The Super Mario Brothers is a good example of that. But a lot of games never had releases in the 50 hertz markets, and sometimes when they did it, they didn't do a good job of that conversion. And even with these fixed conversion titles, a lot of times they're just not as good. The playability is not quite there compared to the original 60 hertz version. Luckily, those problems kind of went away with the later generations of the console. Basically, once we got to 32-bit, like PlayStation, as far as I'm aware, really was no playability differences between the PAL versions and the NTSC versions, other than like for speed running. I think there's some slight timing differences, but playability-wise, pretty much all the same. But in the 8-bit generation, it was quite a big problem. And that's what I really want to figure out with this, is what is it like to play on an actual 50 hertz console, not just emulation, but on something that's outputting PAL. So that's why I bought the PAL version. Now, if you end up buying the PAL version like I did, and I intend to do this actually, is I intend to just swap the NTSC chips into this console. And I'll probably take these chips out and put them into a front loader, because I like this little tiny console. I think it's very cute, and it'll be fun to take to a meetup or whatever. And I happen to have a number of front loader NESs, so I think I'm just going to do the conversion and swap these chips around. Now, it's not as simple as just swapping the chips, because you also have to swap the crystal oscillator. And I can just make out the oscillator that's on this, 26.601712 megahertz, and the NTSC oscillator is 21.47727. So this will need to be swapped over along with these two chips. Luckily, as you can see, this front loader board actually has these in sockets already, so that's perfect. I don't even have to desolder these. We need to see if this thing works, and let's see what kind of quality this thing is. Does it have clean audio? Is the video clean? Are the levels correct? Is it compatible? I won't know fully about the compatibility till I swap this over to the NTSC version, of course, with the crystal, but let's give this a try as is. In fact, first thing I'm going to do is let's get the screws out of here, and let's take this thing apart. I mean, there's not a whole lot to see, right? Because we can kind of see what's going on. And let's see the build quality. Okay, well, the top piece is in multiple parts. Okay, there's a lot of multiple pieces. So that's broken. I could probably try gluing that together. And then the side piece, that's also snapped. That side piece is intact, and the front piece definitely 3D printed. A couple little push buttons for the 2 switches. We have a power switch here, reset on the right side. Bottom acrylic piece, that's in good shape, luckily, and so is the back piece. And then we just have some standoffs. Now, I was just sort of thinking about this PCB design. I wonder if this was a design in China, or if is this actually like some kind of a homebrew thing that they just started manufacturing. Because looking at this, the small size and the small surface mount chips just mean that this would be quite easy for a homebrew project to have this be assembled at like JLC PCB or something like that. And you could just order this pretty inexpensively and just supply the 2 chips from, say, another NES, like if you have one that's broken, like this one, and then cartridge connector and like the other through-hole components. And that could possibly be a very inexpensive way to get a reproduction NES as well. Starting with the power stage, we see a little bridge rectifier, and it does say 9 to 12 volts. So almost certainly this thing will take, AC or DC without any issues, although there's not a lot of capacitor stuff going on here. So I wouldn't necessarily put AC into this. Really should have a larger capacitor for that filtering if this is actually taking AC. But the polarity doesn't matter if it's a DC, and then this uses a little buck converter, which means this thing should be really cool running and not generate any heat because there's no linear regulation happening here. Hopefully it's not noisy though. We can see that red paint they put on these chips. That one definitely looks like it's been lasered off. I'm not so sure about these. So I'm going to get some acetone and try to clean this up a little bit. Okay, here we go. This is acetone. Let's see if it just takes this right off. Oh, it sure does. Look at that. Interesting. All right, my fingers look terrible, but I got all that paint off. At least these 2 chips didn't have anything rubbed off, but all of the surface mount chips did. Well, except for the bridge rectifier. What a funny situation. These are definitely just the SRAM chips that are on the regular NES. They might be even larger capacity. It's just the extra capacity doesn't really do anything. And it's hard to know exactly which these packages are, but I think a little bit of reverse engineering because the schematics for the NES is easily obtainable. And then you can figure out exactly what those chips are. Okay, so to investigate these 2 chips, the PPU, which is the UMC part on here, it's a 6538, and this is the Dendi NES compatible PPU. So as I mentioned earlier, the NTSC version of the Famicom and the NES, they use the 21.477272 megahertz crystal, and they use the Ricoh 2A03 CPU, which also produces the sound, and the Ricoh 2C02 PPU, picture processing unit. The CPU clock speed itself is 1.789773 megahertz. It's essentially the clock rate divided by 12. The PAL version of the console released by Nintendo themselves ran on a 26.601712 megahertz crystal, which is exactly what this console has. Has a Ricoh 2A07 and a 2C07 for the PPU, 50 hertz, and it is 26.6 megahertz divided by 16. So the CPU actually runs a little bit slower, 1.662607 megahertz. But since it's only running at 50 hertz, you theoretically have more time for the processing because, of course, you have less frames per second. Now, from my understanding, where the original PAL versions of the NES run into problems is right here, PPU dots per CPU cycle. It's 3.2. So even though we have less frames at 50 per second versus 60, the fact that the CPU is running slower means that you actually have a little bit less processing power per frame, even at 50 hertz. And that can affect some games. Games that are really tight with their timing, when you're running them on a PAL console, on an original PAL console that is, well, then you run into some issues where you can get garbled stuff on screen and other issues because of the fact the CPU runs out of time to generate the graphics for each frame. So the Famiclone makers, they came up with this Dendi thing, which is still a PAL output. It uses the UMC 6527, which is the CPU that's on here, and the 6538, which is the PPU that's on here. It runs at the same 26.60172 whatever megahertz, but the CPU clock is divided by 15 instead of 16. So the clock speed of the CPU is much closer to what it is on NTSC at 1.773448 megahertz, as you can see. And these consoles still output a PAL video signal, but the timing is actually a lot closer. So PPU dots per CPU cycle is 3 as opposed to 3.2, which means, as far as I'm aware, compatibility is actually better with the Dendi clones than the original PAL clones. Now, when Nintendo made the original PAL version of the console, the Dendi is the same, has the same active graphical area as the NTSC console, well, -1 scanline at 239, but the actual visible picture is more. So you actually end up with borders at the top and bottom, because with NTSC, with overscan, you're only seeing like maybe 224 lines or between 240 and less than that. While PAL, since it's running at 50 hertz, has more lines vertically, and therefore you get 268 scan lines or so visible. And of course, the active graphic area is only 239, and that produces the bars on the top and the bottom. Everything looks a little bit squished. Nintendo themselves only ever made NTSC or PAL consoles. They never made any of these Dendi consoles that were supposedly more compatible. It was always the clone manufacturers, and I think it was UMC that originated the idea. And I kind of have to imagine that the Dendi compatible chips are super plentiful and common out there, which is why when you order this as the PAL variant, you're going to get Dendi chips in here, which means they're not original Rico chips, and it's going to be cheaper. Now, I do think clone manufacturers like UMC made PPUs and CPUs for the NTSC market, and they have a different part number. And the NES Dev website is excellent about documenting all that stuff. So it's quite possible if you order one of these in NTSC variant, you might get UMC parts as well. Although I know when you order the Lava RSC, or at least when I got this one, it did come with genuine Rico chips in here. So they were pulls from probably a scrapped Nintendo or Famicom. And that means that they didn't have any glitches or any other issues. They were 100% compatible. Because one of the issues with the UMC CPUs is that they have some oddities with the sound. And I can never remember exactly what the problem was with the sound, but I'm assuming we're going to hear it on this. And that's where I think the waveform on 2 of the channels is swapped. And even the blob NES is like what's in that Famiclone that I have, or the CPU and the PPU and everything is in that single blob. It has the same problems because it was probably derived from stolen information from UMC's CPUs. Don't know the exact lineage on that, but that problem seems to exist in all of these. Anyhow, I think that's enough talking. Let me get this hooked up and see if this thing actually works. And if it does, then let's do a conversion to NTSC and see how it works as an NTSC console. I've decided that before I plug this in to the capture setup, I've gone ahead and I set up a regular front loader NES. This was with all stock chips inside, so we can compare the video and the audio with this to this. And I went ahead and I adjusted everything on the RetroTink, so I think it looks pretty much as good as it can get from a stock NES. So let's take a look at 240p test suite, just so we can have a baseline of some of the outputs from the stock NES. So you might notice there's a little bit of jail bars. They might be really hard to see, but I can notice them. They're not too bad though. Here's the monoscope output, looks pretty good. The gray ramps have a little bit of color fringing in some of the dot patterns. And this is a particularly good test because you can see if there's any kind of ringing or additional sharpness being applied around the white lines, those boxes on the solid gray background. And this test here shows us that we are running on a stock NTSC console, and there is the CPU speed. Now, one thing that's really useful for testing these inputs is the input test on 240p test suite. So the serial analyzer is specifically very useful. Now, this particular NES controller, of course, only has 8 inputs, up, down, left, right, A, B, and start and select. And that's what you're seeing right here. Now, you can actually have a Super NES controller plugged into the NES, and then you will get more buttons shifted in because, of course, it has the extra buttons on the face plus the shoulder buttons, and those will show up in that next block. You can actually have up to 16 buttons connected to one controller input, although no software is really using it. Now, if I move this to the second controller, we can see where those appear, and those appear under 4017 on data line 0. So now we're looking at those buttons. And you can see when I unplug it, those additional bits go away that aren't being shifted out by the controller since it only has 8 buttons. Okay, so everything is plugged into our clone console. Let's see if this thing works. Oh, it's a little glitchy. That's interesting. Now that might be the EverDrive. Okay, we're getting a little bit of glitching even here. Now I'm wondering if there's an incompatibility with this EverDrive and these Dendi type CPUs. So let's go right to CPU clock speed. And there you go. You can see that we're running at 50.01, but the CPU speed is 1.776 megahertz. And we saw earlier that the clock speed on the actual PAL NES was 1.5 or 1.6. So not as close as the NTSC one, which is what we're looking at here. Now, right off the bat, looking at the video quality, I'm going to say that this does not look as good. There are some lines that seem to be kind of moving up the image. I wonder if that's the voltage converter that's on here. And then we also have some diagonal looking jail bars, which are interesting. And then another issue is I can tell that the video output signal on this is too hot. So it should be 1 volt peak to peak. I think it's going higher, 1.5 volts maybe. Also this, yeah, the gray background was darker on the actual NES on the front loader here than it is on this console. Now we're also getting a good number of sparkles, and I'm wondering if that's a problem with the EverDrive that I have, this clone EverDrive, or maybe this is a problem with the clone PPU that's on here. It's going to be hard to say. We're going to have to swap over to the NTSC ones and see if that works a little bit better. Over here, it's also looking just a little bit too bright overall, although it's funny because the black level also looks fine. So the problem is the whites are too hot. The voltage is too high compared to the black. Lots of sparkles on this particular screen, and it just, that's disappointing. That does not look very good. Okay, so this is what I really wanted to see is the serial analyzer. All right, so I am plugged into the first controller port, and it looks exactly like it does on the front loader. Controller port 2 looks exactly like it does on the front loader. And plugged into controller port 3, aha, yes, we are on D1 now versus D0. It's going to be my assumption that this fourth port is going to be D1 on 4017. And yes, there we go, we're on D1. So I'm pretty sure that's going to work exactly like those extra controllers plugged into the Famicom 15-pin port. Yes, the D1 line from controller port 1 and 2 is available on the 15-pin Famicom port, along with D2, 3, and 4 for controller port 2. Now to use D2, 3, and 4 on both of those addresses, you do have to use extra pins which are not on this console. Those would be on the 15-pin port or at least on the expansion connector on the bottom of the front loader. That's not even totally true. On the front loader NES, it looks like each of the controller ports has D0 and D3 and 4. So D1 and 2 are missing, and they are found on the expansion connector on the underside of the console. On this clone console, it looks like the controller ports 3 and 4 are at least wired up to D1, but they might also be wired up to D2 instead of D3 and 4. It's hard to know. I don't have any controllers that I can plug into those pins. Now I'm really curious to see what's going on with the sparkle issue. Let's see if using my NTSC Super Mario Bros. Cartridge produces those same sparkles. Nope, there's a lot of interference though, so that's kind of ugly. Oh, and interesting, as I just put the controller here in port 3, sure enough, yeah, it's working like normal. Now we should have sound. Let's turn up the volume. Oh no, I didn't plug the sound in, so we have no sound. Wow, that really is like playing in slow motion. The music is so slow. And then of course, this does have the audio bug, so that sounds funny as well. And then the interference is pretty terrible. At least there's no sparkles. As far as the video signal looking terrible, I have a feeling that might be part of the video output circuitry that's right here on the board. But part of the issue might be this PPU. These UMC ones might not be that good. And perhaps I should just try swapping over to the NTSC one so we can really kind of rule out that those chips are the problem and really try to figure out where the problems are with this board with the visual artifacts and of course those sparkles that are coming on this EverDrive cartridge. So first thing we're going to do, let's pop the PPU out and let's put in the NTSC one without changing the crystal oscillator and let's see exactly, well, what happens. I'm sure this is just not going to work properly, but I don't know, let's just see what happens, right? So let's look at the status screen, and when we turn this on, it just says no signal. So whatever video signal is getting generated by this is not something that the RetroTink can even understand at all. I just took the CPU out. There are some of our additional logic chips that I couldn't find. They're underneath. And why is this blob here? It's kind of soft, but that's funny. Anyways, let's pop in the Rico 2A03, which is the NTSC CPU. And now let's see what happens. Nothing. Okay, well, they really aren't happy running at the wrong clock speed. So let's swap over the crystal next. I've already gone ahead and I've removed the crystal from that donor board. And I have a little socket here to install, so we'll be able to swap back and forth relatively easily. All right, the socket's installed along with the crystal oscillator. Let's see if this thing works now. All right, we get a video signal. There's no cartridge, so okay, that's good. Oh, and there's a little bit of interference, but it's certainly a lot less. Let's get rid of the menu there. Ah, interesting. Okay, well, let's try Super Mario Bros. First. Well, yeah, so video's way too blown out. That's why the sky color looks weird and the text is sort of fuzzy. All right, so let's look at what we see here. The blue background, which the color looks weird because again, the video signal's too hot. We do not have the diagonal lines anymore, but we definitely have vertical jail bars. So it almost feels like those were coming from the PPU itself, this Dendi PPU. But we definitely have that sort of background pattern that's moving around, and that is obviously coming from the power supply. It's gotta be. The audio is obviously working perfectly at this point, but you know what? I have an interesting test. I want to take out the NTSC CPU, and I'm going to put in the Dendi CPU, the 6527. I don't want to see if that does anything at all, or maybe we just get pure garbage. Okay, let's see what we get now. Well, there's a lot more interference, it seems like. This CPU just works, and it... Oh. Did you see that slowdown? So this is really intriguing. I wonder if the CPU is just running at the wrong speed. The sound's obviously way off, but there's some strange stuff happening there, and I kind of like it. It's just interesting and glitchy. Let's go back to 240p test suite. I want to see if we have that weird... Okay, I was going to try to go to 240p test suite, but this EverDrive clone is not working. It is not happy at all with this fake CPU, obviously. And I can't even start the 240p test suite. That's very interesting that that didn't work. Let's try Super Mario Brothers 2. Okay, the video problem, this is the retro tink. I just got to turn it off, turn it back on again. Okay, now it's doing the green screen thing. I just have to pull the power out of this thing and plug it back in. All right, third time's a charm. I don't get why the video is so blown out. I don't see how that has anything to do with the CPU. But who knows? Oh, the slowdown is so much worse than it normally is. So yeah, we definitely have the CPU running at a slower speed, even though we obviously have working graphics and everything. Oh, the slowdown is wild. And this part of the game doesn't normally slow down. Wow. This is quite interesting. I gotta say, quite interesting. Okay, let's go for Super Mario Brothers 3, MMC3 game. We got one note. Oh, the game is running. Oh, what a disaster. And the video, it's just wild. Part of me is surprised that the video is so screwed up because I figured the video is either working or not working, not this sort of halfway in between thing that we're looking at. Okay, I have Bionic Commando, one last cartridge to try in this sort of rude setup. This doesn't work at all. So let's put back in the correct CPU, and I'm sure this game is fine. No, this game is not fine. Well, so much for my like full compatibility that I would have sworn that this thing actually has. How about Super Mario Brothers 3? Yes, this is fine. Could be a problem with that cartridge. I mean, the background looks so messed up because, of course, we have the video level problems. Interesting that there's a lot less interference with the correct CPU, right? I mean, this looks really quite fine other than the video level problems. We don't have any slowdown issues. And let's go back to the clone EverDrive and let's see if this is having the sparkle issues or not working. No, this works fine. And are there sparkles? I think even with like a front loader NES, you occasionally get a few sparkles in the menu, not in the games, but in the menus. And here's Bionic Commando running off this cartridge, this is fine. Let's try one more time running the incorrect CPU with the EverDrive. No, okay, I thought it was gonna work and initialize, but clearly not. And I'm hitting the start button, which should just start the previous game, and it's not doing that. And I wonder if this Bionic Commando cartridge, oh, now it works fine. Okay, I must have had a bad connection in there. So this is the wrong CPU with Bionic Commando. The music is so weird sounding. See how the game plays though. Oh, glitchy, glitchy, glitchy. Oh, how funny. I love this. This is like experimentation here. Game is still playable. It's just obviously glitchy. There's some serious slowdown with this game now. Of course, you know, this thing is slowing down all over the place. And I'm so used to this game, I played it so much that anywhere there's slowdown where there isn't normally, I'm so affected by it. And I bet, oh yeah, slow down, so slow, so slow. Now I am playing through OBS, which makes playing really difficult. Normally you would split the video signal and then play on a CRT and then have OBS capture as well. But the game's working, it's just really slow and very glitchy. Of course, the scrolling is all messed up. Okay, so obviously we have issues. First thing I think I want to do is try to figure out what's going on with this interference problem. I'm totally believing that it's going to be this power circuit up here. There's just not enough filtering going on. All right, I did a little probing around, and it looks like this thing can accept two different footprints for two different regulator chips. This is 5 volts, and that is ground. So theoretically, I could just take a capacitor and solder it into those two pins, just sort of bend it over here, and then that should add a little bit more capacitance to the output of this. These 4 capacitors that are all parallel together, these are the actual output caps for this regulator circuit as well. So if I add electrolytic, it will just enhance that. But I might also try adding some filtering on the input side. So there's our 5 volt regulated output. That's where I would put a cap for the output filtering. And for input filtering, it appears to be right here, 7.833 volts. This is the drop after the bridge rectifier. This is a 9 volt power supply, so 9.4 volts. But the output is on this side of the rectifier. Yeah, there it is, 7.8 volts, which is the same as this, which seems to be the same as this. So I'm going to start by installing this 100 microfarad 16 volt cap. And I'm just going to use these little pins, holes that are there for that dip IC that's not installed. All right, so there's that cap. Now I need to install one from that outside pin to the ground pin, which is the pin on the far right here. Now I'll just do that on the bottom side since there's space. And on the 9 volt side, I'm just going to start with this small little disc capacitor. We'll see if this makes any difference. Maybe it's slightly better, but we definitely still have kind of a crosshatch pattern. Okay, so what I'm going to do is I'm just going to have the game running here, and I'm going to try to connect this capacitor across where this disc capacitor is. Does that make any difference? No, I don't think it makes any difference at all. It's hard to see that pattern sometimes. It kind of comes and goes. The cap that I am connecting up, by the way, this is, what's this? 100 microfarad 16 volts as well. Yeah, I don't think it's any better. I really don't think it's better. Super hard to tell though. Now I'm holding it across the regulated output. That doesn't really seem better either. So now this has me wondering, maybe we lack the bypass capacitors for the CPU and the PPU. It's quite possible they're mounted underneath the chips because we saw that there were other things mounted under there. But I'm wondering if that's something that I need to deal with. So on both of these chips, ground and 5 volts is between pin 20 and pin 40. So those two corners, which is this corner and that corner. All right, so this is just a test. So I just sort of bodged this 104 capacitor between ground and 5 volts on the PPU. No, that doesn't really look better at all. Now what I can do is, now that I have 5 volts and ground close to each other for the PPU, I can use this capacitor and I can touch the legs here and we'll see if it improves the noise. I'm going to say no, that makes no difference whatsoever. And let's see if feeding 5 volts directly from my bench power supply right into the 5 volt circuit on here actually makes it not have any interference lines. Yeah, I don't see any interference lines. Well, I guess it's kind of noisy, like in the brown Super Mario Brothers background. Interesting, but we just don't have those moving lines that we had before. So that's definitely coming from that buck regulator that the power supply on this thing is using. It's just the filtering is just not appropriate. It's not good enough on it. NES is using 248 milliamps, by the way, so relatively low current draw. And if we go back to the built-in power supply here, turn this on. Oops, well, I ran Duck Hunt, but yep, there are those lines in the background. I'm going to spend a moment to try to figure out how to clean this up a little bit more, and I'm sure I can do it. It's just, I got to figure out the right combination of capacitors. Okay, I think I have this fixed up as good as it can get. Having worked with this a little bit, the design is frankly terrible. Basically, look at these traces. They're just laid out in a haphazard way with no consideration of anything to do with analog noise, which of course, this is an analog console. It is very affected by the routing, and this thing does a terrible job. These fixes I've done are like putting lipstick on a pig. It really isn't going to make something beautiful unless you absolutely love pigs, which this thing is just, yeah, it's not great. Okay, what did I fix? First off, video output. So that's the composite video output jack. I found that the video output circuitry, which are these two transistors, they simply had the output of that transistor going directly to the jack with no 75 ohm termination. Well, that's just wrong. So I cut the trace and I added a 75 ohm resistor in line, and that seemed to fix all the video level problems. As far as the power problems with the noise from this buck regulator, they didn't have any inductor on the output. So that's what I went ahead and did. So that hole right there in the board, that actually feeds this trace, this thick trace that makes its way to the power switch. If you can believe it, the power circuit is always running. Power switch is after that circuit. So this was the easiest place to cut that trace, and it's cut underneath this inductor. So it goes into that hole right there, which is the 5-volt output, and then it's soldered onto the trace right there. I tried a few different inductor sizes just to kind of see which was the right fit for this board, and well, it was a compromise no matter which one you picked, but I think this one is probably the best. I think this one is around 1 microhenry. If you look carefully at those stripes, silver, silver, brown, blue, I guess, or maybe it's the other way around, that will tell you what the value of that. And then I added some capacitance afterwards. So these are just between ground and the main 5-volt feed. So we have 10 microfarad, that's a ceramic cap, and this one's 104, which I think is 100 nanofarad, also ceramic disc capacitor. And that makes its way to the power switch, and that just goes to the rest of the board. I tried adding this bypass cap to the PPU. That's the ground pin, but it's connected up to these ones as well. So it was closer. I just wanted to try that. That made absolutely no difference. This disaster routing on this board just results in horrible picture quality. And I think there's really no way to solve that. But at least now everything's not overblown with this component on there, and the power is a little bit cleaner with this inductor and these capacitors in the 5-volt rail. They really didn't even bother with that stuff. This thing, like I said, was designed by someone who has no clue how analog circuitry should work. I also didn't really mention, but they use the cheapest possible connectors for the NES controllers, and the fitment is frankly horrible. Like the controller port 1, I mean, it's barely in there. It just pulls out so easily. All of these are like that, except for, strangely, that one. Controller port 3 actually has a firm connection, and 4, I think, is just as bad as the others. Yeah, it's pretty bad as well. I think the connectivity for the controller, like, it actually makes contact if you really push it in all the way, but you could just see how loose the fit is. Just disappointing, very disappointing. Okay, so let's turn this on. I want to demonstrate something. Sometimes you see a little bit of interference in this screen, although it kind of looks fine right now. When interference does show up, like it's not showing up right now, you can tell that a lot of the digital signaling is being picked up by the video signal, because when I hold down the reset switch, it actually makes the picture much, much cleaner. Right now, you're not really seeing it, but sometimes the interference patterns are pretty visible. Oh, okay, there we go. Now you can see those patterns. Watch when I hold down reset, they go away. So that really shows us, due to the bad routing of this board, digital signals are interfering with the video output, and holding down the reset button kind of seems to cure it. All right, so here we are, 240p test suite, and we are running completely with the NTSC chips on here. Otherwise, I wouldn't be able to use this EverDrive. And on this particular screen, you can really see a lot of interference coming through from the digital side of this into the analog side. Those diagonal lines are entirely interference that are picked up and has nothing to do with the power circuit. In fact, watch, if I hold down the reset button, okay, well, the colors change, but you notice there's pretty much no interference anymore. There's still some jail bars, and there's maybe the slightest interference from the power circuit. But most of this interference that we're seeing here is entirely the digital side leaking onto the analog side, and there's really no way to easily fix that without completely re-engineering this board, and it's just not worth it. The original front loader NES motherboard does a much better job at preventing this interference than this board does. I'm just checking the serial input test here. This looks totally fine and is working. It seems actually like controller port 3, the one that's a little bit tight, kind of has a bad connection as well. As I jiggle it, kind of comes and goes. The other 3 loose jacks though, they're totally working fine. Now, as I mentioned, this controller port 3 is like the external controller port on the Famicom if you're using one of those adapters to use external controllers. And I think almost all games, or all games, will work with the controller plugged into this port as the first controller. So let's give this a try and just see which games actually work with a controller plugged into port 3, and Bionic Commando, no problems whatsoever. Super Mario Brothers and Duck Hunt, this was a North American release, and no problem, this works completely fine as well. Okay, here's one that does not work. Super Mario Brothers USA does not work hooked up to the second controller port. This game was only ever released in North America, and I just moved it to controller port 1, and now we're working. Boy, those diagonal interference lines are very visible, very, very visible. So I suppose games like this one that were never supposed to be released in Japan don't work with the controller over on port 1. Let's just make sure that it's still not working. Yep, nothing. Super Mario Brothers 3, this was released in Japan first, and yep, no problems. Even though this is the North American release, the code that allows you to use D1 for the main joystick or the main control pad, still there and still functioning. How about a modern release, Montezuma's Revenge? This game does not work with that controller in that port. Yep, it definitely only works with the controller in this port. And the developer Montezuma's Revenge did not target people using Famicoms with a joystick adapter. How about Micromages? Micromages does work, on the other hand. So these developers, they wanted to have full support for people with Famicoms using external joysticks. It goes without saying that Japanese release games, this is gimmick. Obviously, this is going to work, since this was designed for Famicoms in mind specifically. Here's Galaxian. This was only ever released in Japan. Of course, this game totally works, and this is my modified version that has the much faster firing, which is a much more pleasant game to play than the stock version. Even though the stock version is much closer to the actual arcade version, I like this version better. Here's Pac-Man Championship Edition. This is a downgrade, or downmake, I think it's called, or downport. Can never remember the exact term for it. And yep, this one is working. I was able to start the game without issue. One thing about this game, if you are going to try to play this, this does have extra audio. So if you have an EverDrive, you need to modify the console. So, well, one of these EverDrives that uses the North American connector, you have to modify your console to route the audio properly. If this console were a little less crappy, I'd probably spend the effort to figure out how to use a resistor to mix the audio from the cartridge with the CPU's audio, but this thing is so junky, I don't really care. I randomly picked Jeopardy to see if this worked, and this does not work. And now this, of course, would not have been released in Japan, so I can totally understand why this only works with the controller plugged into the first port. Yep, there we go. Okay, enough of that. I'm going to put this motherboard that has the Dendi chips and the Dendi crystal oscillator into my front loader so I can see what the picture quality is of these chips in a properly designed motherboard, or a better designed motherboard at least. The reason why I can't just run it on the bench is you do need to have like the power switch module and the controllers from one of these front loader cases hooked up to the board. The one thing I'm going to do on this Dendi unit is I'm just going to put some of this deoxit on this connector here. This stuff is the D100. It's super concentrated. Okay, let's see if this thing turns on. Now there's no cartridge, so we should just have... Okay, we get that. That might be normal for what these do. There's no lockout chip on here, or it's disabled. All right, so let's start with Super Mario Brothers 1. Okay, there we go. I have to put some deoxit in this cartridge connector. I had to try a few times to make it work. Okay, that looks kind of terrible. So a lot of those issues that we saw originally were from these chips. In the brown Super Mario Brothers box, there are horizontal lines, and then of course we have these diagonal lines all across the image, and I'm pretty sure that's coming from, you know, these chips internally. Now we already heard how the audio sounds earlier, slow and weird. But yeah, this is a PAL console now. Colors are a little bit more vibrant than they are on the NTSC, and I don't know if that's the same as you would get on the original NES console, but of course the composite video is formed inside the PPU, and they can change up the way the color palette looks, and this is the way this particular PPU looks. Let's try out the clone EverDrive. Let's see if it has those same sparkles that we saw on the cheap console. Now it's funny because this cartridge did work in the other console with the same crystal and these two chips, so I'm not sure what's happening here. Yeah, no matter how much I put this in, take it out, it does this every time. That's weird. Let's try this cheap 154-in-1 cartridge. Oh, this one worked. I heard the sound. So Zelda works. It's real slow. It's not glitchy though. Oh, well, that was a bit of a glitchy transition there, wasn't it? Yep, that's weird how it draws the screen there. Either way, it's working at least. Contra works. It's just really slow. Super funny. Bomberman 2 works as well. It's just really slow. So if you need a little help with these games and you want them to play more slowly, PAL is a good way to do that. At least if you're playing on the versions that were released in North America and Japan. Also, what's kind of funny, I swore the background color is green on this game. I need to swap back to an NTSC console real quick just to check that. But not this brownish color. Okay, ooh, look at those. Look at that interference. Back on the NTSC version. So far everything looks good except the colors are just a little bit less saturated. Oh yeah, it's kind of a greenish color here. That's very curious there. Most of the colors look very similar, but this one, it's obviously quite a bit different. Also, the aspect ratio of the playfield, of course, looks a little bit more, well, what I'm used to. I'm not going to say it's right or wrong. Nothing like classic Bomberman. I gotta say, I always like this game quite a bit. And recently I actually played through the entire game, start to finish, although I did use the EverDrive, so I had save states available to me. And that was mainly only so I could stop and resume the game, come back to it later, because there's no save state in this game. Although maybe there's passwords, I can't remember actually. Just who could be bothered to write down passwords when you have save states? They're just easier and better to use. I think that's all there is to really say about this NES clone. Should you buy one of these things? No, absolutely not. This thing is not good, and even with these mods that I've done, it's only kind of okay. I like that it's so small, and to be honest, I'll probably just keep this around for testing CPUs and PPUs, but I really would not recommend you spending your hard-earned money on this. Let my loss be your gain. And the only good thing about me buying this thing is I did end up with a Dendi CPU and PPU, which are installed in this front loader now, which is nice for just testing PAL stuff in the future. It's really a shame the design of this thing is so lackluster and frankly crappy, because they could have done a better job, and then this would have been an awesome little NES replacement board. It's so small and compact, and of course being a top loader means that you don't have any issues with the front loader mechanism going bad, which even on this one after some deoxide, it's pretty good actually, but it's still slightly flaky. But I honestly just cannot recommend this thing because of all of the analog electrical issues that exist on this. And I really don't feel that there's any way to really fix this fully, not without an entire new PCB with much more careful attention paid to how the analog signals are routed on this board. So there we go. If you found this video interesting, I would appreciate a thumbs up, but if you didn't, you know exactly what to do. Huge thanks to my supporters, huge thanks to my subscribers. If you're not a supporter already, you can do so with links in the description below. Subscribe if you haven't already subscribed, thumbs up, thumbs down, all the usual YouTube stuff, comment down below, and I guess that is gonna be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.